Next we'll move on to the topic properties of intersection of set. So this is our topic, properties of intersection of set. In the previous topic we have seen properties of union. Properties of union of set we have seen. So in that we have discussed these 5 properties. Okay, these 5 properties we have discussed in that topic. So among which this first property is called a commutative law. This second property is called associative law, and this property is called law of phi, and this property is called idempotent law. This property is called law of u means universal set. So these are the name of these 5 property. Okay, commutative law, associative law, law of phi, idempotent law, law of u. So these are the name of the property. Similarly we have properties of intersection of set. So among in this property we have 6 property. Okay, first property is called property of sorry first property is called commutative law. Okay, first property is called commutative law, second property is called associative law, this property is called law of phi, and this property is called law of u means universal set. This property is called idempotent law, this property is called distributive law. So these are 6 property that we will discuss in this topic. So first is A intersection B. If I take an example of set A has this element 1 2 3, set B has elements. Okay, so if you find A intersection B, so A intersection B is a set of common elements of A and B. Okay, common elements. So A and B has only one common element, which is 3. Similarly, I can find B intersection A. So you will get again 3 only, because B and A has again that same element common. So we will have element 3 in the set. In the set we will have element 3. So either you find A intersection B or B intersection A, the set will be same. The set will have only common element of A and B. Okay, so therefore these are equal. A intersection B and B intersection A are equal. That is the first law. Second we have to prove this one. Okay, so we will use Venn diagram to prove this. It will be much easier, and you will get a understanding to how to draw Venn diagram, or to how to use Venn diagram to prove such conditions. If this type of condition is given to you, you can use Venn diagram easily to prove these conditions. So for that we will draw Venn diagram. This is set A, this is set B, and there are 3 sets. So by default we'll assume that 3 of these sets are having some common intersections. Okay, now this is set C. These are 3 set A, B and C. So these are 3 set A, B and C. So first we will prove left hand side. First we will prove this left hand side. Okay, so to prove left hand side, what is left hand side? A intersection B intersection C. This is left hand side. So first we will shade the region for A intersection B. So which is the common region for A intersection B? That is this region. This is the common region. Okay, this is the common region for A intersection B. Now we will shade we will shade the region for C. We'll shade the region for C. What is the region for C? This is the region for C. Okay, this is the region for C. So what we have done here, first we have shaded the region for A intersection B. Okay, which is this region. Next we have shaded the region for C. This is the region for C. Okay, now A intersection B and C has intersection, means we have to shade the region for common of these 2 regions. Okay, so common of these two regions are only this region. This region is common between these two. So So final common region will be this region, this region, this region. Okay, this is the region. This is the region A intersection B intersection C. So in this shaded region is A intersection B. In this shaded region is C. In this shaded region is, okay. So this shaded region is actually A intersection B. This shaded region is actually C. This shaded region is actually A intersection B intersection C. So how we have what was the approach to draw the Venn diagram? First we have shaded the region for A intersection B. Then we have shaded in the next diagram we have shaded the region for C. Then we have found out that the intersection between A intersection B and C means the common region between A intersection B and C, that was this region. Okay, that we have drawn in the final Venn diagram. Similarly, we will go for the right hand side. In the right hand side, it is A intersection B intersection C. This was the right hand side. Okay, so for the right hand side, we will shade the region for A. So to shade the region for A, this is the region for A. Okay, this is the region for A. So this is the region for A. The shaded region is region of A. Next, we will shade the region for B intersection C. We will shade the region for B intersection C. So this is set B, this is set C. The intersection B intersection C is the region of this region. This is the region of B intersection C. Okay, this is set B, this is set C. So what is the common region? Common region is this region. So that is B intersection C. So this is B intersection C. Okay, so B intersection C. Next we will shade the region for A intersection B intersection C. Means what is the symbol A and B intersection C? In between these two, what is the symbol? This symbol. That means we have to find the common region. We have to find the common region between these two diagrams. Okay, and what is the common region between these two diagrams? This is the common region. This is the common region. Okay, that is the common region between these two diagrams. So we will shade that one. This is a common region. So this is basically A intersection B intersection C. Therefore, now you can see left hand side. This is the left hand side diagram. This is right hand side diagram. Both the diagrams are equal and both has same shaded region. Both has same shaded region. That means these two are equal, and that means I can say that A intersection B intersection C is equals to A intersection B intersection C. Okay, so I can say this is equal. So therefore, I have proved that the second property is true. Now we'll move on to our third property, which is what? Which is phi intersection A. Phi intersection A. So how do you prove phi intersection A? Let phi be the element, phi be the set. So phi is actually null set. That means phi do not have any element. So phi intersection A. So what are the common element between phi and A? There is no element common because phi does not have any element. Phi do not have any element, so, and A has some element, so there are no elements common. There are no elements common. That means phi intersection A is also a null set because they do not have any element common. Phi do not have any element. A has some element. How can there be any element common? Okay, so there are no elements common. Therefore, the answer is phi. So this is the proof for third property. Next is the fourth property, which is universal set intersection A is A. How do you solve this? So now let's say A is the subset of B. Okay, let's say A is the subset of B. Then A intersection B will be always A. In this case, A is the subset of B. That means A has all the element in B. So what are the common element? Common element are A's element are the common because this is the subset and A has all the element in the B. Okay, So the elements of A, all the elements of A are the common elements. That is why A intersection B is A. So this is a similar case. Actually, this is a similar case for the for this law. Okay, in this case, you can see A is the subset of U. This is universal set. Okay, this is A. Now A is the subset of universal set. Now if A is a subset of universal set, then obviously A intersection U will be always A. Therefore this property. Therefore this property. Okay. So this is basically a thumb rule. This is basically a rule to remember. If one set is the subset of another set, if one set is a subset of another set, then their intersection will be the subset. Okay. Now we have seen a similar property in the previous topic, and what was that property? That was if A is subset of B. If A is a subset of B, then A union B will be always B. This we have seen in the previous topic. This we have seen in the previous topic. So if A is a subset of B, if A is subset of B, that means this set is a subset of B. That means B is the superset in both cases. Okay, B is the superset and A is the subset. In case of intersection, A intersection B, the answer will be A. But in case of union, A union B, the answer will be B. Okay, so this is a thumb rule to remember. Next, we'll move on to the next property, which is the property is A intersection A. So A intersection A intersection A. So these two sets are equal basically. A has what those element A has same element this A will also have. So these two are equal set. That means all the elements are common and all the elements belong to A. That means that A intersection A will be equal to A. These are equal set, no? These are equal set. That means these set have same number of element and same identical elements. So the common elements will be every element, and every element belong to A. That will be, therefore the answer is A. Next we'll prove this distributive law. We'll prove distributive law. So we will use again Venn diagram to prove this. So A union, let me check, A intersection B union C, then A intersection B union A intersection C. Okay, this is left hand side, this is left hand side, and this is right hand side. So now first we will draw the Venn diagram for left hand side. So first we will shade the region of A. So this is the region of A. This is the region of A. Okay, this is the region of A. Next we will shade the region for B union C. Next we'll shade the region for B union C. So B union C means this is the region for B union C. Okay. The region occupied by B and C. So this is the region for B union C. Okay. So we'll shade that region. We'll shade that region. So this is the region for B union C. This is the region for B union C. Okay. Now between these two, what is there? Between these two, intersection is there. Between A and B union C, what is the symbol? Intersection is the symbol. So basically we have to find the common region. So in both of this diagram, which is the common region, so you can say the common region is this region. This is the common region. Okay, this is the common region. This is the common region in both this diagram. Okay, so we will draw that. We'll shade that region. in the next diagram. So the common region is, this one is the common region. Okay, this one is the common region. So this is basically A intersection B union C, and this was B union C, and this was A. Okay, so how did we approach? First we have shared the region for A, then we have shared the region for B union C, then we have shared the region for the common region between A and B union C, that is A intersection B union C. Now this is the final shaded region for the left hand side, that is A intersection B union C. Next we will draw the Venn diagram for this one. So first we will shade the region for A intersection B, then we will shade the region for A intersection, sorry, first we will shade the region for A intersection B, then second we will shade the region for A intersection C, then finally we will shade the region for both of their unions. Okay, first we need to shade for A intersection B. So first we will shade the region for A intersection B. Okay, so basically this is the common region for A intersection A and B. So we will shade that region. Next, so this was first step to shade the region of A intersection B, means common region of A and B. Next we will shade the region for A and C, common region for A and C, that means A intersection C. So which is the common region for A and C, that means this is the common region for A intersection C. Okay, next in between these two, what is there? Union is there, union. So in union what we do? We do combine, we do shade the we do shade the region of both the set. Okay, so we have to shade the region for A intersection B and A intersection C to get the union of these two. Okay, in union what we do? In union we basically shade the region for both of them. Like if we need to find the region for A and B, or you can say A union B, if we are going to shade the region for A union B, so we shade the region for A as well as B. Okay, both. Similarly, union is there between these two. In these two, between these two, union is there, that means we have to shade the region for this as well as this, both. So this was the region for A intersection B. Okay, and this was the region for A intersection C. So in while so what we did here, we combined both of them. Okay, then we will get the region for A intersection B union A intersection C. Okay, so how did we what was the approach to draw the Venn diagram for the right hand side? First we have shaded the region for A intersection B, that was this region. Then we have shaded the region for A intersection C, that was this region. Then we need to find the union of these two, that means we have to combine both of them. Okay, That is how we got this region. You have to combine both of them. Now you can see, so let me name first. This was A intersection B. This was A intersection C. Now you can see here, this shaded region is same as this shaded region. That means we got the same Venn diagram. We got the same Venn diagram. Therefore, this is equals to this. So that is how you can prove the distributive law. So this was all about properties of intersection of sets. Properties of intersection of sets. Okay. Then after this we will move on to our next topic, which is properties of complement. I think. Let me check. Yes, we will move on to properties of complement.